Welcome to True Projects. In this video, we are going to explain about a project titled Earthquake Landslide Prediction using Deep and Machine Learning. Natural catastrophes like earthquakes and landslides pose a grave risk to human lives, infrastructure, and ecosystem. The accurate anticipation of these events is paramount in minimizing their devastating impact and safeguarding the life. Conventional method of earthquake and the landslide prediction often rely on historical data and the geological assessment, which have inherent limitations. However, recent strides in the deep learning and the machine learning present the promising avenue for more precise and timely prediction. This study aims to delve into the potential of these cutting-edge techniques for the earthquake and the landslide prediction. By harnessing the sophisticated algorithm and the extensive data set, our goal is to highlight the prediction precision while reducing the false alarm. This multidisciplinary research amalgamates the insight from the seismology, geology, and the data science to formulate the innovative model with the potential to revolutionize the landscape of the disaster anticipation. This study endeavors to analyze and assess a spectrum of machine learning models dedicated to the landslide prediction. With the primary emphasis on the deep learning architecture, the objective is to discern the most effective predictive model for the landslide, underscoring the significance of incorporating the temporal and the spatial data within the data-driven algorithms for enhanced accuracy. Furthermore, the research delves into the constraint inherent in present-day technique for the landslide susceptibility mapping. It deliberates on the potential of the deep learning methodology to surmount these limitations by leveraging their ability to comprehend the intricate pattern and the relationship within the complex geospatial data. This exploration not only aims to identify the superior prediction model, but also to pave the way for the refined methodology that better align with the dynamic nature of the landslide events. And these are the basic requirements that are needed to build this project. The software requirements are Python IDE with version of 3.7, Anaconda with version of 3.7, or Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the package. This step involves importing the essential Python libraries such as pandas for data handling, NumPy for numerical operation, and the relevant machine learning framework like TensorFlow or PyTorch for the deep learning model. And the next one is exploring the dataset. The dataset containing the earthquake and the landslide data is loaded and explored to understand its structure, feature, and the data distribution. And the third step is data processing. It addresses issues like missing values and outliers. It ensures that the dataset is suitable for the analysis and the model training. And the next step is visualization using Seaborn and the Matplotlib. Data visualization tools like Seaborn and the Matplotlib are utilized to create the visualizations that offer the insight into the feature distribution, correlation, and the potential pattern within the data. And the next step is feature selection. Feature selection techniques are employed to identify the most relevant features for predicting the earthquake and the landslide. This process helps to optimize the model performance by focusing on the key attributes. And the next step is building the model. And the first one is addition of CNN plus LSTM. It integrates the convolutional neural network and the long short-term memory network, enhanced with the attention mechanism. This advanced architecture allows the model to focus on crucial features within the input sequence, aiding the accurate prediction of earthquake-induced landslide by capturing both the spatial and the temporal pattern. And the second one is autoencoder CNN plus LSTM. It employs an autoencoder to extract the intrinsic features from the input data, followed by the integrating CNN and the LSTM network. This hybrid approach aims to enhance the model comprehension of the complex relationship and the earthquake and the landslide data, resulting in the improved predictive accuracy. And the next one is random forest. It is a traditional ensemble technique that aggregates the prediction from the multiple decision tree and the context of earthquake-induced landslide prediction. Random forests serve as a baseline approach, providing the insight into the performance uplift achieved by the deep learning model. And the last one is voting classifier. It combines the prediction from the two distinct models about random forest and multi-layer perceptron. This ensemble strategy leverages the diversity in the prediction from both the models to attain the more robust and reliable earthquake-induced landslide prediction. And the next step is the user gives the input. User input represents the conditions are taken as input with the help of the Flask as an web interface. The given input is pre-processed for prediction. The provided user input is pre-processed to align with the format required by the models, which involve feature transformation, encoding, and scaling. And the next one is trained model is used for the prediction. The pre-processed user input is fed into the trained model, which uses the learned pattern to predict the likelihood of an earthquake-induced landslide occurring based on the input condition. And the next one is final outcome is displayed. The prediction from the models are compiled and presented as a final outcome. This information assists the users in understanding the risk levels associated with the provided input and guide the decision making to enhance the disaster preparedness. And the execution of the project. To execute the project, first we need to open the code folder. And this is the code folder containing of various files within it. The static folder containing of the asserts, CSS, fonts, images, JavaScript folders within it. And the template folder containing of the HTML documents. It typically includes home, index, result, sign-in, sign-up, and notebook pages within it. And the more dataset file we used in this project, and the app is an py file which likely contain the information related to the front-end logic. It includes the code written in Python that handles the server-side operations such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the model is a SAV file which contains the algorithm information and can be loaded into the project code during the runtime to utilize the trained model for the various tasks, such as making the prediction on new data, performing the specific operation. And the signup.db is a file used to be the database for the store user information. And the notebook is an IPYNB file which contains the information combination of code, graph, and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And for the execution of the project, first we need to copy this code folder path and then open the Anaconda prompt. Here we need to write a command that is cd space and paste this code folder path. By this, it will change the current directory to the code folder path. And then click on the enter button. After this, we need to write a command that is python space app.py. By using this command, it will execute the Python script and perform the runtime check for any syntax errors or logical issues. And then click on the enter button. After running this app.py file, the Flask framework will host the application locally at the default address like this. We need to copy this link and paste it on any of the web browser of our choice, and I prefer to use the Google Chrome. I'm pasting this link and then click on the enter button. Here it redirected to this page containing of the title of the project and some details about it. And then click on the sign up button. Here it will redirect to the sign up page containing of some necessary details that are need to be filled to create an account, but my account is already created. That's why I'm using the sign in button containing of username and password, and we need to fill those details and then click on the submit button. Here it will redirect it to this page containing of those details that are need to be filled, and I'm entering those details as of enter the value of V1 as of 140.84 and V2 is of 38.91 and V3 is of 81.32 and V4 is of 55.19 and V5 of 7.64 and V7 of 2.69 and the V8 of 1, and then click on the submit button. Here it predicted the result as there is no landslide due to the earthquake based on the input. and then click on the home button, and here we can re-enter the other details. As I'm entering the other detail of 140.429, V2 of 37.24, and V3 of 44.82, and V4 of 32.09, and V5 of 7.09, and V7 of 3, and V8 of 8, and then click on the submit button. Here I predicted as there is no landslide due to the earthquake based on the input. In this way, we can predict the landslide of the earthquake using the deep and the machine learning techniques. And in conclusion, the research on earthquake and the landslide prediction using the deep learning and the machine learning has shown the promising result by leveraging the advanced algorithms and the vast data set. We have been able to develop the robust prediction model that exhibit the higher accuracy compared to the traditional method. Real-time prediction has emerged as a significant achievement, allowing for the timely response to the potential disasters and the proactive measures to protect the vulnerable communities. The reduction in the false alarms has not only increased the public trust in the prediction system, but also reduced the unnecessary panic and the resource wasted on the non-critical events.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.